Today I am going to explain how we can represent a graph using an adjacency matrix. Now first, what is a graph? A graph is a set of points called vertices and lines connecting them are called edges. One of the most common ways is the adjacency matrix. Let's explore how this works with an example. An adjacency matrix is a 2D array with the rows and columns. If the graph has n vertices, then the matrix will be of the size n by n. Each cell in the matrix is written as A of ij. If there is a direct connection between the vertex I and the vertex j. Let me give you an example. If there is an edge between the 2 points, we have to write 1 in the matrix. If there is a no edge, then we write 0. That's how we have to represent an unweighted graph, just using a zeros and ones to show the connections. But what if the edges have the weights? For example, distance or cost. In that case, we use a weighted graph. Now, instead of writing 0 or 1, we have to write the actual weight in the matrix. So, we say Aij equals the weight if there is an edge connecting the vertex I and j. And if there is a no edge, then Aij is equal to 0. This makes it easy to find out which vertices are connected and what is the weight between them. In short, the adjacency matrix representation is a simple and useful way to show all the connections in a graph using a matrix. Here is a simple, easy to understand with an example. Here it's a directed graph under its adjacency matrix. The graph has 5 nodes numbered from 0 to 4. These nodes are connected by arrows which show the direction of the connection. For example, there is an arrow from node 0 to node 1 and also from node 0 to node 2. Similarly, node 1 connects to node 2 and 4 and the vertices 2 connects to node 3 and node 3 connects to node 4 and node 4 has no outgoing connections. Now let's understand how the adjacency matrix shows these connections. An adjacency matrix is like a matrix with rows and columns, both labeled with the vertex numbers from 0 to 4. Each entry in this matrix tells us if there is a connection from one node to another. If there is a connection from one node to another, the value at the row and column is 1. If suppose there is a no connection, then the value is 0. Let's look at some rows. In row 0, the entries at column 1 and column 2 are 1. This means node 0 connects to the nodes 1 and 2. The other entries in the row 0 are 0. So, no other direct connections from node 0. In row 1, the entries at the columns 2 and 4 are 1. So, the node connects to the node 2 and 4. Similarly, row 2 has 1 only at the column 3. It means that node 2 connects only to node 3 and row 3 has 1 at the column 4. So node 3 connects only to node 4. Row 4 has all 0. It means that the node 4 doesn't connect to any other node. Finally, this matrix is a clear, simple way to show which nodes are connected in the graph and the direction of those connections. But the disadvantage of using this matrix is adding a new nodes in adjacency matrix is not easy. This is because the matrix size has to change and sometimes the order of the existing nodes need to be rearranged. So it can be difficult and take extra work. We saw how easy is to represent a directed graph using an adjacency matrix with full of zeros and ones. Thank you for listening.